But if you, and for example, Coke is one of the companies that had the most stable dividend policy over the last 60 years. If you went to a Coke executive and said, tell me what your dividend is going to be 20 years from now, he'll kick you out of the room because he has no idea. It depends on a lot of stuff that's going to happen in 20 years. But as a kind of a teaching tool, uh, there is nothing wrong with that formula. The trouble is, in practice, there are many issues. One of the issues is uh, somebody has to predict what those dividends are going to be. And two, quality of, even if somebody could come up with some of those estimates, quality of those predictions keep decaying over time. If you know anything about physics, that's called the second law of thermodynamics. It basically means entropy always increases. Entropy is a fancy word for uncertainty or disorder. Okay. In order to predict what's going to happen in 2 years versus 1 year, there is one extra year where things can go wrong, right? So forecast errors associated with year 2 will always have will always be larger on an expected sense compared to year 1. Not even talking about year 20. So in practice, this is not easily implementable. But again, it's a great teaching tool. Other models that we use in the upper level classes use a similar kind of stuff, but based on more predictable stuff. And more importantly, those dividends do not necessarily depend upon what's going on with the firm. It is completely up to the board of directors to decide what those dividends are going to be. I mean, could anybody say that Google has not been doing well the last 25 years? They're doing spectacular, but they haven't paid a single cent of dividends. Similarly, NVIDIA has been doing great, and they only increased their dividends to what, 10 cents a share right now? It's something like that. It used to be 1 cent a share. But Coke, on the other hand, keeps increasing their dividends pretty much at a similar rate every year. But so I'm going to kind of use general philosophy about models, whether in finance or economics or in physics. Models are useful as long as you use them in the context they're useful. Example, could anybody argue that Newton's theory of gravity is a bad theory? No. I mean, the guy came up with all of that when he was 26 years old. He actually had to invent calculus to be able to calculate all those orbits and stuff. If all you want is to predict the orbit of Jupiter 20 years from now, Newton's theory is great. It's going to pretty much tell you almost plus or minus 100 feet where Jupiter is going to be. It's that precise. But if you applied Newton's theory, Newton's law of motion to orbit of Mercury, it's going to fail. Why? Because Jupiter is so far away from Sun, Mercury is too close. Then Newton's theory is not useful there. Can you get accurate prediction of Mercury's orbit? Yes. You use Einstein's general theory of relativity, which basically says, a big mass creates a curvature on space-time that affects how things are going to move. Since Mercury is so close, those relativistic effects are operational. So I wouldn't ever use Einstein's equations, which are horribly difficult to solve, even with modern computers, especially if you have more than two bodies around on, you know, Jupiter's orbit, because Newton's theory gives me pretty close enough. You know, whenever you have low gravity on low speeds, Newton's theory is good. Whenever you have high speeds or high gravity, then you have to go Einstein. Same thing with models like these. Under certain circumstances, they're useful. Okay, so we're going to kind of find simple cases where we can apply this model. And the first case we're going to use, I'm going to call this case 0. In fact, it's a special case of what I'm going to do with case 1, but all future dividends are constant. So next year, we expect $D1 and same every single year after that. In fact, there is a security like that. We call them the preferred stock. Preferred stock technically is not a stock, it's a debt instrument. But for legal purposes, it's treated like equity. Uh, you lend the company whatever money you have, there's a face value on that, let's say $100. And the company promises you to pay, let's say, $10 every year until the end of time or company goes bankrupt, whichever comes first. And for tax purposes, that's not considered a debt instrument because if the company does not pay that dividend, that is not a bankruptable event. A preferred stockholder cannot go to the court and say, these guys did not pay this promised dividend, so I'm suing them for bankruptcy. If a bondholder doesn't get their payments, they can go to bankruptcy court and ask for the company to be declared bankrupt. Because as soon as the company is declared bankrupt, court is going to go through it. The assets are going to be liquidated, and people are going to get their money based on the order of preference. But preferred stock is not something like that. In fact, they're second to last in the order of priority. Only the common stockholders are the last. But you could value a preferred stock like that because it promises to pay a constant dividend. So if I expand this equation, so that, come on, work with me. $D1. In fact, I'm going to write this in summation notation. This is just a fancy way of saying this. Let me call that T. For each year, take that amount, let's say that's $10, divide that by 1 plus R raised to the power T, and add those things up. This is just a fancy notation for doing all of that. Mathematicians like short notations. For example, do you guys know what this means in mathematics? That means for all, or this means for some. This means that exists. They're just like writing things in shorthand. It's a language. Since this is a summation and this is constant that does not depend on t, it comes out of that. This is an infinite sum, and we happen to know that this thing is actually convergent. I mean, first of all, each item gets closer and closer to zero. That's not enough in and of itself. For example, sum of 1 over t equals 1 to infinity is infinity. That's not convergent. It's not enough that the terms get closer and closer to zero. They have to get closer to zero faster than that. But this thing is convergent, and we know that I'm going to write this limit as t goes to infinity